In this example, we're going to look at how you can import and export 3D data into the software. We'll begin with looking at various files that we can import into both VCarve and Aspire, and then we'll look at different file formats that we can import and export in Aspire only. So let's just go and close this down. And before we can import an object into our session, we need to open an existing file or create a new file so that we have a workspace that we can import that 3D data into. So let's go over and create a new file. And here we're just going to put in some dimensions. I'm going to put in a width of 10, height of 10. Material thickness is going to be 1/2 inch. XY position, we'll put that to be in the lower left hand corner. I'm going to go with a very high modelling resolution. We can then go ahead and press OK. And so we can access 3D data by going into the Modelling tab. So we are demonstrating the first part of this tutorial within VCarve, and anything that we look at in VCarve will also apply to Aspire users. And so within the Modelling tab in both VCarve and Aspire, we can use this option here to import a component or a 3D model. And that will allow us to browse the folders within our PC and search for 3D data. Now in VCarve, we're able to search for V3M files, so that's vector art 3D files, and then other 3D mesh files such as STLs. If we look on the drop down menu, so you've got OBJs, 3DM files and all sorts. And we'll look at 3D mesh files that's been created in other 3D packages shortly. With Aspire, in addition to all of these, you can also import Aspire files, that's .crv 3D files, and you can also import 3D clip files, that's .3D clip files, and we'll talk more about those later on in the tutorial. So for now, let's just cancel that. So there's also another way that we can import models into our session, and that's by using the clipart tab. So if we go in there, you can see the top half, we have the library browser, and we also have local files. And so the library browser allows you to add folders that are within your PC. You can search through and browse through your PC for folders that contain 3D data and then look at adding the folder. For instance, I've installed the clipart that comes with the software, and then I've gone in and added all of the different subfolders that were available using the add folder option. And so when I click on one of these, I get a thumbnail displaying that piece of clipart, which I can then take and just drag into my session. Another way is by using the local files option, and this is where we can navigate around the folders in our PC, and then when we go into that folder that has, for VCarve, if it has a V3M, they'll be displayed, and Aspire users will also be able to see CRV 3D files along with 3D clip files. And so that just makes it easier for us to select a folder and easily access what's in there. And so I can just easily select a piece of clipart now and just drag that in. And then if I go into the Modelling tab, we can see that we have a component within our component tree. We can see that component's grayscale. And then if I go to View and tile the windows vertical, we can also see that component in the 3D view. So let's just take that. I'm going to right mouse click. We're just going to delete that. And so the import folder and the clipart tab are the main ways that we can look at importing 3D data into our session. So we're going to start now by looking at importing a 3D model from another design package. So we're going to come back up here. I'm going to use the import option, and in the project folder we're going to select this Porsche.stl file. So if I just select that and then press open, if I just maximize the 3D view over here. Now, because this is a non-native file, the software will automatically open this form on the left-hand side, and that's going to allow us to adjust and position the size of the model before we create a component from it. It will also display the full model to us in the 3D view, and so we can just spin that round, and you can see here that the part that we've imported into the software is a full 3D model of a car. Now, as a component in the software, we can't have a full 3D object because everything is based on our grid of pixels to represent the 3D. And so we can't support undercuts, we can't support anything that has a top and a bottom. And so what we can do at this stage is to orient this model in such a way that we can tell the software which part of it that we want to use to create our component. Now, the first thing to understand is that the model that we've imported is at the size and orientation that it was created in the software program that it was originally modelled from. And so if we come over to the left here, what we need to do is adjust the orientation, and we need to look at the size to match the part that we're working on. To help us keep track, it would be useful at this stage to come over to the View option here, and we're going to select this option to draw origin. And so we can see that we've got these arrows within our model here. And so this is showing us the X, Y and Z directions. So the red arrow is showing us the X-axis, the green arrow is showing us the Y-axis, and the blue arrow there is showing us the Z-axis. Now I could come over and choose one of the standard directions that we've got here in order to start the orientation process. So at the moment it's orientated so that we're looking down on the model, and now these words that we've got here just purely represent the directions on the model the way that it was actually saved. They have no concept of the fact that the car has a bottom, top, right or left. In fact, in this case, if we look at it from this left view here, then we would actually be looking at the back of the car. And so if I click on the left, we can see that the car is now orientated up, and that, as I said before, it's purely to do with the part's original orientation from the software program that it was saved in. And so you're just going to look around at the options that we've got here and choose the correct one for your object. In this example, I'd like to have the side of the car prominent, so I'm going to go and choose the front orientation. And so now we can see that we're looking at this from the front of the model, and now that that's up in the Z-axis. So as well as choosing the direction, we can also choose to rotate the object around the Z-axis. And so we could just click different options here in order to move that around. And again, this is just to help us get the orientation. We could, if we wanted to, just do this after we imported that. As well as the standard directions, we also have the ability to interactively rotate the model, and that allows me to put this at an angle rather than look at it specifically from one of these directions. Now by default it's set to rotate the view, and so if I click in the 3D view and move this around, you can see that my origin moves and the grey plane moves as well, and so that just shows me that I'm just looking at this from a different view. Now if you choose one of these options over here, that's just going to rotate the model. And so if I click on the XYZ model rotation, you can see that the origin and the plane are staying in the same position, but I'm able to rotate the model. Now as well as rotating in X, Y and Z, you might want to fix the axis of rotation. And so we could click over here on the X-axis to rotate this around the X-axis only, or we could choose the Y, or we could choose the Z. And again, this just helps us to get the model into a position that isn't one of the standard directions that we have at the top over here. Now if you do want to go back to the standard directions and ignore the interactive rotation that you've just made, you can click on any of these options up here. So if we just press top, and that will reset the model, then we'll go back and put that to the front view. So we no longer have any of the rotation applied, and now I have the side of the car in view ready to create a component from. So now I'm going to come down and start thinking about the size of the part. So I just want to take a moment just to point out this grey plain area that you can see here. Now this is no indication of my work area within the software, this is just a divider, and we'll see how we use that shortly. This red square, however, is an indication of my work area, and so we can see that the car is bigger than the workspace that we set up earlier. We can also see that by looking at the X value in here. We can see it's just over 14 inches, and we know that our job is set up in a 10 by 10 space. And so we can see the Y and the Z values are also working in inches here. Now if I keep this lock XYZ ratio checked, and when I go to change the value of one of the X, Y or the Z, it's going to scale that in proportion. So I'm going to change the X value here. We're going to make that 9 inches. And if I press apply, we can see now that's fitting within my square. So it's now fitting within my job space that we've got. You can come down here, you can change to go into millimeters if we wanted to. And we could scale millimeters and inches by 25.4 and back down by 25.4. Make sure we've got inches set so that's the right unit for my part. And then the center model button would allow me to reposition my entire model so that the date and position is back to the center of the part, so the XYZ would now be in the center, and that can be very useful if you've been doing a lot of rotations or manipulations of the part where it may have gotten out of position. So once the model's been orientated and sized, we need to choose how much of it we want to convert into a component. And this is done by positioning this grey plane that we referenced earlier, which is called the 0 plane. Now if I look at this down the y-axis, we can see this line represents that grey plane, so this is the 0 plane. And then if I use this slider bar here, and if I just move that, we can see that it moves relative to the model, and so it's cutting it in different positions. Another thing that we could do is just press the middle button, so that puts it directly in the middle, and then if we press the bottom, so everything goes from the base of the model, and so everything would be converted as a component. If I wanted to, I could indicate a value. So maybe I just wanted the top 1 inch, so I'll put 1 in there and then I'll press spacebar to enter that in. So now we can see that just the top 1 inch of the model sticking out above the 0 plane. In this case I'm going to click the middle and set that back there so that it's in the centre of the part in terms of the Z-axis. So the last option we've got here is to create both sides. So at the moment, as I said before, we're just currently, if we went ahead and okayed that, we'd just create a component that represents everything above that 0 plane. And if we wanted to, we could use this option here to create both sides, and that will enable us to create a component that represents what's above the 0 plane and a component that represents what's below the 0 plane. And so then I could slice that up in the software in order for us to create a full 3D object again by cutting and reassembling those pieces. And so we'll have a look at that option there. And Aspire users have an additional option at the bottom of the form to apply perspective along Z, and this will apply a perspective distortion along the Z-axis. So I'm just going to go ahead now and press OK. So the software will create 2 components, so it looks a little bit odd at the moment. We can see the 2 components are in our component tree here, so we've got Porsche top, Porsche bottom. So if we just go to view, I'm just going to tile our windows vertical. I'm going to take the bottom, just going to select that, hold down shift and just bring that down just to keep that in line. Then I'll take the top one, just move that up a little, then take this one, move that, and then we'll go into the drawing tab, just use the rotate tool. I'm going to put the pivot point in the centre. I'm just going to rotate that 180 degrees, press apply, then we can close that down. So if we just go ahead and maximise the 3D view. So one important thing to notice here, and we've talked about before, is that we've lost all of the undercuts of that model. We can see that everything underneath the aerial and underneath the wheels is just a solid piece of material. And there's nothing that we can do about that because we have no way of supporting an undercut in the software. And in most cases that's absolutely fine because we can't machine these undercuts either with a 3-axis machine. So once we've imported any file into the software and we've created a component from it, then we could go and work on that the same way that we would with any standard component. So we could take it, we could rotate it, we could edit it, we could look at the various modelling functions that we have available to manipulate the components as well. For instance, we could take this car here and then we could apply a smooth filter in order for us to smooth out some of the facets that are in there. So let's just go in there, apply a smooth filter. That will do that at a default of around 50%. You can see that's softened that a little. And so this faceting that you can see here, these triangles, were already in the model when we imported it, and that's how the file was saved. And that's fairly common in models that you may find on the internet that you can download that are in mesh formats. And so if you're creating the parts yourself in another design package, then you can normally control this by what tolerance you set when you export the part. So let's just go and cancel that. So we're actually going to close this session down and we're going to open up a new session in Aspire. So the rest of this tutorial will only apply to Aspire users only, where we'll look at other file formats that we can import into the software, and we'll look at ways that we can export 3D data too. So let's just minimize that. So we're in Aspire now, so let's go and create a new file. Again, we're going to go 10 inches by 10 inches. Let's go with ½ inch, XY position in the lower left, very high modelling resolution, and we could go ahead and press OK. So in Aspire, if we go into the Modelling tab, so we can see that folder that import a component or a 3D model. We also have this option here to create a component from selected bitmap. So this will allow us to import an image and generate a component based on the light and dark shades within it. And we'll take a look at that option later on. So let's just go back into import a component or a 3D model. And we can see in the project folder that the software will look for Aspire files, so .crv3d files, and 3D clip files that we've got here. We'll also search for V3Ms and STLs like we spoke about earlier. So if we look on that drop down menu, so you can see it's the same as VCarve, except we have the addition of CRV3D and 3D clip files. The first thing that I wanted to show you is the difference between a 3D clip file and a CRV3D file. Now we know that we can save a CRV3D file, and that's going to contain all of my vectors along with my layers and 3D components and any toolpaths that I may have calculated within the file. But if we import a component from a CRV3D file, so if I just double click on that, then what we're going to get is just a single component which represents the composite model within the design. So basically it's what it can see in the 3D view at the point that the file was saved. So it's important to note here that it imports at the size and place that it was originally saved in. So if that's selected, I'm just going to come over to transform objects. We're going to align that. We're going to align that vertically and horizontally to the centre of my material. Then we could close that down. So if I just go to the 2D view control and tile the windows, we can see we just have a single component here. We can see the grayscale, and we can also see that in the 3D view. Now if we take a file from within the software and it's a group of multiple components and it's exported as a .3D clip file, then the 3D clip file will retain these individual components as information within it. So let's just take that, I'm just going to move that over to the left hand side for now. And we're going to come back up to the import a component or a 3D model option. And then in the project folder, we're just going to import the fleur-de-lis 3D clip file. So I'm just going to double click that. Again, let's just move that, drag that out the way. And so this was exported so that the individual components were in a group. And I can see that by looking at the plus symbol next to that fleur-de-lis components. That's telling me that that is actually a group. If we look in the 3D view, we can see that they look and act the same at the moment, but because this component here has individual components, I can actually see those by clicking on that plus option here, so I can see them, or I could select the actual group here, right mouse click, use the option here to ungroup, and I'd be able to access all of those individual pieces within that group. And then I could take them and just move them around. And I could edit those if I wanted to. So this is only going to apply if my 3D clip file was exported with those objects as separate components within it. And so if you are saving files that you may want to use as clipart in the future, the best bet is to export them out as .3D clip files and use those as your clipart rather than access files that are in a CRV 3D file. But as we saw earlier, it is possible to import a component from a CRV 3D file, but it will import as a single object regardless whether the composite model is made of different parts. And if you didn't have a 3D clip file, you could always open the .crv 3D file in another session of Aspire, and then you could copy and paste the individual components from that into the current session that you're working with. So I'm just going to go and just box select all of these. I'm just going to right mouse click and use the option to delete. So now that we've looked at the different options for importing either 3D files that are native to Vectric software or importing models from other software programs. So now let's look at how we can import a 2D file and create a 3D model from that. So let's go over to this option here to create a component from a selected bitmap. We can see in the project folder that I have image files in here. And when I click on one of these, the software will create a component based on the light and dark areas within that image. And so the white areas in an image will be the highest part of the component, and the black areas will be the lowest, and all shades in between will be assigned a height and interpreted based on how light or dark they are. So this is very good if you have a specially prepared image like this fleur here. So we're going to open this test.tiff file, so I'm going to take that and press open. So if we just take that, just make that a little bit bigger, and we can see that the black areas have been given the lowest height, and the lighter areas in the image here, we can see that there's a lot more height in there. And so you can see that we've got a good clean model that we can work with minus this flat plane here. But most images that we would work with would just be standard photographs or things that we've scanned. I'm just going to put that back in Z. I'm going to take that, I'm just going to right mouse click and delete that. And so let's come over to the create component from selected bitmap, and we'll look at importing standard photographs. So we'll go in there, go into the project folder, I'm going to bring in that house.jpg file and press open. I'm going to take that, I'm just going to go and alter the size of that, so just give that a width of 9 inches, press apply, close that down, we'll take that, go over here to align selected objects, we're going to align that vertically and horizontally to the centre of my material. You can close that down. And so if we zoom in on the 3D view, we can see that there's quite a lot of noise here. So what we could do is look at using the smooth filter. So let's go in there, and this will help us to control the amount of noise that's in that component. And so it looks okay if I just maximise the 3D view. And so all it's done is created a texture. And we're not really going to be able to carve this and see the same thing that we'd get if we actually modelled this as a 3D relief. So to show you this a little bit better, what I'm going to do is I'm just going to scale this up. So I'm just going to put an exact height here. I'm just going to scale that up to 3/8 of an inch. Press apply, and then we'll just close that down. And so if we just twiddle the view there, we can see that it's not really something that's practical for us to machine. And the reason that I show you this is that it's a common misconception within the software that you can just import an image and generate something that is the equivalent of someone creating a relief model. But what this is useful for, though, is creating textures that we could apply over the top of a 3D model or for a textured background. So let's just cancel that. I'm going to take that component, right mouse click, I'm just going to go and delete that. So let's just go and tile our windows, I'll put that in isometric view. We'll come up to the modelling tools and create a component from a bitmap. We're going to take this post image and look at creating a texture from that photograph. So let's open that up. Okay, so I can take that, if I wanted to, I could just make that a little bit bigger. So I can see that we've got a photograph that shows a post that looks pretty weathered. So let's take a look at the component that we can see in there. So if I wanted to, I could again use the smooth option. So let's apply a smooth filter to that and just reduce some of that noise there. Okay, so I'm happy with that 50%, that's okay. So we could go ahead and OK that. And then if I wanted to, I could look at scaling that model. So if that's selected, let's go into the properties. You could look at maybe just reducing that down to 0.08, space to enter that in. If we just maximise the 3D view, then we can close that down. We can see that we have quite a nice texture there. So if I wanted to, I could look at just taking a selection of this component that we've got. So let's go back and tile our windows. And what I could do is go into the drawing tab, draw a rectangle, just draw into that post area there. I could close that, I could take that component, hold down shift and select that rectangle vector that we just created. We could go into the modeling tab, we could use the option here to clear area of selected component outside of selected vectors. We can see that we just have a textured panel there. And so I could use that in another project. And there's definitely potential for using component images, but it's good to understand the limitations too. So depending on the quality of the image depends on the quality of the model that you'll get. Now if I import a JPEG, a bitmap, a GIF or a PNG, then that's only going to find 256 Z levels from the model. And so if I have a lot of shallow curves, then as I scale that up or down, then we may actually see stepping on it. If a file is saved as a 16-bit TIFF, then the software will interpret up to 65,000 levels in that, and so you'd get a much smoother model. But those 16-bit TIFF files and those sort of grayscale files tend to be extremely specialist files that have been specially prepared as a kind of grayscale height map. One application that you'll see this is making terrain maps, and you can find more information about that on the Vectric user forum. So I'm just going to go and just box select this and then just delete that. Put that back in isometric view. So I've seen a number of ways that we can import data into the software to create a 3D component. We also have ways to export 3D data in different file formats. Typically in Aspire the end result is to take your model and the vectors, calculate your toolpaths and then run those toolpaths on your CNC machine. Some cases you may want to save the 3D data. One way is to save the files as native Aspire files, so that's your CRV 3D files or your 3D clip file formats, so that you can import them back into the software and use them as pieces of clipart in other designs. You may also want to export data as another format of 3D model in order to take that into another design package and use that as a part within another software program. We can also take 3D data and export it as an image file, and that may be something you'd want to take and put on a laser. Or it may be something that you'd want to take into a photo editing program in order to use the editing tools in there and then resave and re-import back into the software. Now these are fairly specialist applications, but I am going to show you the techniques to export different types of files now. So let's just go to File. I'm just going to go and open a file. And from that project folder we're going to open the fleur2.crv 3D file and then press open. So let's go and tile our windows vertically, and we're going to go into the modeling tab. Now because we opened the file and we didn't import it, you can see that we've got all of the individual components for the part. As we saw earlier when we imported that CRV 3D file, we just got this as a single object. So now we're going to look at the export as 3D clip file options. So if I wanted to, I could take any one of these components. If I wanted to export an individual component as a piece of 3D clip, I could right mouse click, use the option here to export as 3D clip art, and you'd give that a name and you'd save that out, and then you can access that in another session. So I'm just going to go and cancel that. Another way we could do this is if we wanted to group components. If I selected all of these three components here, right mouse click and use the option to group, and then what I'd like to do is export this group out as a piece of clip art. I'd right mouse click, use the option again to export as a piece of 3D clip art, and then once I've saved that I can then go and access that and it will retain everything within that group. So again, let's just cancel that, and I'm just going to go to edit, I'm just going to undo that group there. If I wanted to export everything within a level, I can do so by selecting the level, right mouse clicking, use the option here to export as 3D clipart, would give that a name and save that out, and it will retain everything within that level. Now if I wanted to export the overall composite model out, or if I had more levels, then I could go and use the model option up here and then use this option here to export as a piece of 3D clipart. And again we'll go ahead, give that a name, and we'll just save that out, and then we could access that and it will retain all of the information within the composite model of the component tree. And so this is a more powerful way if you're trying to save objects for other sessions of the software. And in any session you can open up the clipart tab, you could browse your local files, search for the folder where you saved out or exported your clipart to, and then you could take those and just easily drag them into your session. Or alternatively you could locate the folder and add in that folder so you'd always have it in the lower half of your clipart tab. We can also take any set of components in the software and export them as STL or OBJ mesh files. It doesn't matter if they're grouped or not. We can see that we have a bunch of components that are ungrouped, and if I use this option up here to export composite model as an STL file, the software will take the composite model and use that to generate the STL mesh. And so we're going to define the quality of the mesh either by using a tolerance or a maximum number of triangles to generate that model. So in here I'm going to go with a tolerance, and I'm going to put in a tolerance of 1/1000th of an inch, and then we're going to use this option here to triangulate. And so this will display the mesh and it would output this if we pressed save triangulation. If we just maximise the 3D view, and if we just zoom in there, we can see the faceting in here as we get closer. And if we go and use this option here to draw shaded triangulation, we can see this as a wireframe drawing. And so you can see all of those triangle facets. And so if we make this value smaller and then go ahead and press triangulate, then we get a much finer mesh. And so if we just switch on the draw shaded triangulation, we can see that there is no faceting in this model. We've got a nice, smooth, denser mesh. And so this will be a much larger file in terms of memory size. Now, as well as controlling the quality of the mesh from defining the tolerance and triangles, we can choose how we want to close the part off. So by default we have the leave open no back face option selected. So if I rotate that around, we can see that that's hollowed out at the back. If I choose the close with inverted front, we can see that that's just created a full 3D and it's just got a copy of that front onto the back there. Or we could choose the close off with a flat plane, and that will just give us a flat plane on the back. So the last two options here, the close with inverted front and close with a flat plane, you'd probably want to use with a 3D printer, as it would normally work better if it's completely sealed off. So once you're happy with those settings and you think it looks correct, you could go and save out that triangulation. If we use that drop down box, you can see that we can save that out as an STL, an OBJ or a POV scene file. So this is a specialist shaded file. So typically you want to save that out as a .stl file, and then once you've saved that you can import it into an appropriate program that supports 3D mesh files, or you could take that straight to a 3D printer. So let's just cancel that. So let's just close that down, and we'll just put that in isometric view. So now we're going to look at a method in order for us to export the model as a 2D image. And again, whatever the software can see as the composite model is what will be exported. So let's go over to Model. We're going to use this option here to export as a grayscale bitmap. And in the Save as Type option here, just going to use the drop down menu, and I'm going to select the 16-bit TIFF. And so that'll export that at 65,000 levels of grey. And so I could give that a name, go ahead and press save, and that will be a 2D representation of the 3D model, and any transparent or modelling plane will be black and the highest parts will be white. So that concludes this tutorial where we've looked at how we can import and export 3D data into both VCarve and Aspire, where we started off by looking at the various files that we can import into both VCarve and Aspire, and then we moved on and looked at the different file formats that we can import and export into Aspire only. And you can access all of the files that I've used in this tutorial in the Import Export 3D project folder.